All right, so we have fixed the parenthesis here, and then we are going to look at the blue notes that will be going on page 36 when we're done, okay? So identifying transformations, which you have done before, okay? You may not have done as many altogether, but you've done them. The order in which we write them matters, what we write matters, and how we do this, because then when we go to graph, everything starts to come together on how we find all these things, and we got to make sure we can handle all this correctly. So it says, given each function, identify both the parent function and the transformations from the parent function. So I actually want you to write 3 things down before we even worry about what the transformations are, and they all revolve around the parent function. So when we look at number 1, what would be the parent function of that function? Or what kind of parent function is it? What's it called? Cubic. Okay, so we're going to write down cubic because that's the name of it. Then we're going to write the actual equation for it. And since this is f of x, we'll use g of x. And since it's cubic, it would be x cubed. And then we're also going to sketch a little picture of what it looks like. So use your arms and show me, what does the parent function of a cubic look like? Right? Kind of something like that? Right? Okay. Don't be afraid. It's all good. Looks like this. You gotta know what it looks like. Okay. Uh-huh. Kind of goes up. All right. Kind of goes like this. I'm a little teapot. Actually, there's another one that looks a little bit more like a teapot, but yes. Okay. So then, in this specific one, how many transformations are happening? One. Just one, so the order doesn't even matter. And it is it a stretch, a compression, a translation? What is it? Translation. All right, so this one we are going to translate where? Downward. Down 4. Okay. We all can handle that, right? We think. Okay. So number 2, what is this one called? Square root. Okay, so this is a square root function. And that means that would be, keep wanting to write f. G of x is equal to the square root of x. And then what does this one look like? Kind of like if my body is the y-axis, then it's going to look like this, right? So that one's kind of what makes me think of the teapot, right? Just your little teapot sitting out there. It's going to look like, okay, that's your square root function. So when you see a function, you should think of what the parent function would be called, what the equation would look like, and what a sketch of the parent function would look like before all the transformations and stuff happen. Okay, so the order in which we write our transformations down does matter. The exact order could be a little bit different and we still be right. What can we not do first? Translate. You can't translate first. It's still an order of operations thing. You have to do your multiplication and division before you do your adding and subtracting. Okay, same idea. So I can't do the translation first, but I can look at this 2, right? So that 2, would that be A, B, C, or D as far as what you have on your reference sheet? A, right? It's going to be A, and so A is affects me vertically or horizontally? Vertically. And so would this be a vertical stretch or a compression? So this is a stretch, and the factor is 2. You want to be careful by just putting like by 2. That means that, you know, what does by 2 mean? The factor is 2 means it's being multiplied by 2. All right, so then this negative sign, a negative sign means what kind of thing is going to happen? A reflection. So this is going to be so we're going to reflect, and then since it's where it is it going to be a reflection in the x-axis or the y-axis? The y-axis. And so here was been some confusion all day, is that you got it when you're talking about, does it directly affect the x or does it directly affect the y? If it's happening inside of whatever the parent function is, so in this case it's a square root, so everything that's happening inside that square root is affecting x. So you're changing the sign on x, and that's why it's a reflect. That's why you reflect in the y-axis. Okay, does that make sense? All right, so then I've got my 2 taken care of, I've got my negative taken care of. Then this means I'm going to do what kind of thing? Translate. Okay, so I'm going to translate right 1. Okay, everybody good with that? Now, when I said that the order matters, but it could be a little bit different, these two things could be flipped around, right? I just can't do this before I do the others. Because the order in which you write them would also be the order in which you actually do them when we go to translate or transform. And so you want to make sure that you're thinking about them in that order too. You always do the translations last. Okay, so let's look at number 3. What kind of function is this? Quadratic. It's a quadratic. And so this is equal to x squared. All right, show me with your arms. What does a quadratic look like? Everybody, don't be afraid. Everybody's arms up. You're not too cool to be a quadratic? Okay, thank you. Here we go. Alrighty, so we can start, we just know we do the last. So let's just start with this negative sign. The negative sign means that we are going to reflect somehow. Would this be a reflection in the x-axis or in the y-axis?
Oh, x-axis.
X-axis. It's on the outside. This y reflect in the x-axis. Yeah, whatever that was. X-axis. Okay. So I've taken care of my negative sign. Then I've got this 1/4. Does that 1/4 affect me horizontally or vertically? Horizontally. Okay, so it affects us horizontally, right? So it's a horizontal something. Is it a stretch or a compression? A stretch. Okay, so it's a horizontal stretch by a factor of 4 because the x is the opposite. So instead of 1/4, it's the reciprocal, which is 4. So we've taken care of the negative. We've taken care of the 1/4. Now we've got this 6. So this means we're going to translate 6. Everybody okay with all that? Yes? Alrighty. So number 4, what is this? Absolute value. And that would mean g of x is equal to the absolute value of x. All right, so what's the value going to look like? All right, much stiffer than your quadratic. Some of y'all, those of you that think you're too cool to be a function, you're really not that cool. All right, so we've got this. Now, do I have any reflections going on here? No, there's no reflections because we're not multiplying by a negative anywhere. So this 3 here, does this affect me horizontally or vertically?
Vertically.
Okay, does it happen inside or outside of my absolute value? Inside. Everything that happens inside affects x. And anything that affects x is a horizontal thing, right? So this is going to affect me horizontally. So this is going to be a horizontal, is it a stretch or a compression? Compression. And the factor would be what? 1/3. We good? Because the big confusion has been, is it affecting x or is it affecting y? Well, y is our f of x. Nothing's going to be actually literally over here, right? But the idea is when you substitute in x, when you think of your little function machine, right? You got input and output. When you substitute it in and you do your thing with x, whatever it may be, whether we're squaring it or absolute value or whatever, that's affecting the x value you put in there. Then you get some value out, that's your y value, but then you change the y two more ways before you go any farther. Does that make sense? So you just look at it inside and outside of the function part itself. Okay, we good? Now, then let's see, that's the only multiplying I have. So then I have these two things. Those are both what? Translations. So I'm going to translate left 5, okay, down 2. Everybody okay with that? Anybody have any questions? All right, I want you to work on the next 2 on your own. I'll give you a couple minutes to do it. Alrighty, so let's look at number 5. And Alexis, tell me what is this called? What kind of function is this? Quadratic. so this is a quadratic. So g of x equals what? X. All right, let me see your best quadratic. Woo, good job. Okay. You're laughing at her.
She was like this.
She was ready. She was practicing in her head. She knows to ask her. Okay. All right, so Alex, help me then. What is this 1/2 going to do? What is this?
Oh, it is going to vertically compress it by a factor of 4. I mean 2.
Okay, so we're going to vertically compress. Oh, I guess I could just say vertical compression. I mean, vertically compress is fine. It's the same idea, but less writing. Vertical compression, and my factor is what? 2. 1/2. Why is it 1/2 and not 2?
Because Abigail told me it's 1/2.
Okay, which one? You were the one that said you didn't like that x lies. Remember, x lies. Y does not. So the vertical compression, what you see, it's a 1/2, and plus if it's a compression, it has to be less than 1. But since it's 1/2, that affects the y. It is 1/2. It's x that it's the opposite of what you see. Okay, that's why we say x lies. And then what does that 6 do?
You're gonna go right. Oh, it translates to right.
Good. Translate right 6. Y'all agree with that? Yes. We all good? Okay. All right. So then, let's see. Vanessa, what is this next function, number 6? Okay, so it's reciprocal. So this would be g of x equals what? 1 over x. All right, let me see your best reciprocal. Yeah, I know, it's kind of the same way. Like, I don't know, maybe it's a little easier to do with your hands. You know what I mean? I don't know, but okay, good job, though. I see what you're trying. That one's a little tricky. But it looks something like this, right? Something like that, but a whole lot better. Okay, so let's then... That's okay. I know, it's a harder one. All right, so let's talk about this one together. Negative, that's going to be a reflection, so we're going to reflect in something. What's it going to reflect in? Vanessa, what do you think? X-axis or y-axis? Y, with a question mark. What do y'all think? Y'all think it's y? How many of you thought it was x? Okay, and how many of you thought it was y? Okay, so let me explain something to you about this. So that negative's like out in front of it, right? If I have negative 2/7, which has nothing to do with this problem, but if I had that, isn't this the same as 7, which is also the same as 2 over negative 7? Okay, so if I could write it any of one of those 3 ways, and it's all the same, right? Technically, this is outside of the reciprocal part of it, which means it's affecting y, which would be a reflection in x. However, I could write it as 1 over negative 4x, right? Then I'm affecting x, which is a change in which reflects it in the y, right? Seems weird, but here's my little parent function, right? Looks like this. If I reflect this in the x-axis, or if I reflect it in the y-axis, it's going to be the same thing. Okay? So does it really matter? It doesn't. It doesn't matter when you're actually doing it graphically. Now again, officially, the way that it is currently written, that is affecting the sign on y, which means this would actually reflect in the what? X-axis. In x-axis. Okay. All right. We all good with that? All right. So then, let's look at that 4. That 4 is directly affecting what? X. So we would say that it is a horizontal what? Compression, and the factor would be what? 1/4. But I'm going to blow your mind again, right? Because this negative 1/4 x plus 3. Couldn't I write this as negative 1/4 times 1 over x plus 3? Is that the same thing? Like when I just multiply straight across, wouldn't I just get that back? Yes? Okay, so now here's my reciprocal function. This 1/4 now represents a what? A vertical compression. So when you have a reciprocal, and only with the reciprocals, okay, that doesn't work for the other parent functions, so don't go trying to apply this to everything. It depends on how it's written, or you could write it either way, and you could argue it either way, and you're both right if you're arguing about the same thing here, is that I could say that it has a vertical compression of 1/4 or a horizontal compression of 1/4. It doesn't matter, you end up with the same thing in the end. And actually what we're going to do when we start to graph them is we're going to take an original point and we're going to do both things so we can get more than one point out. Remember when we did our parent functions, we only had 1 point. We used them in the asymptotes, right? So if I take this 1 point and I reflect it in the x-axis and then I horizontally compress it and then move it up 3, it's going to give me 1 point. And then if I take this and I reflect it in the x-axis, do a vertical compression, and then shift it up, it's going to give me a different point. But they're both on the graph. Like eventually you get all of your points either way. Okay. So for the reciprocals and the reciprocals only right now, that it works either way because it just you can argue on how it's written. We'll go with horizontal because that's actually how it's like written here for real. All right. So then this plus 3 would mean that we do what? Translate up 3. Bless you. Bless your soul. All righty. So let's look at 7. We'll just go ahead and do 7 together. 7, what kind of function is this? Cube root. So this is a cube root. Okay. The g of x would equal the cube of x. All right, let me see your best cube root. Kind of like walk like an Egyptian type of thing, right? All right. Something like that.
It was like the Nile dance.
Yeah. All right. So we've got a negative. Just start with your negatives. Like the more consistent you are with what you do, the easier things become. So if there's a negative sign, we'll just start there. We know that that means there's a reflection. So we're going to reflect. And then because of where it is, would we reflect in the x or the y? The x, because it's outside, which means it affects y, so it's reflect in the x-axis. Oh my gosh, I am having trouble with that word axis. I cannot write it. Okay. So I'm reflecting in the x-axis. Then I look at the 4. Does that 4 affect me vertically or horizontally? Vertically. So this is going to be a vertical what? Stretch. Vertical stretch factor of 4. So I've got all my multiplication stuff taken care of. So then I can just look at the adding, which means those are translations. I'm going to translate. That 1 tells me I do what? Left 1 and up 2. Okay? See how easy that is? You just break it up. Don't try and do everything all at once. All right, number 8. This is not an absolute value function. That's actually like a double thing. It's the greatest integer, but it's the one that we decided to leave off, so we're going to adjust this one. We're going to change this one to be f of x equals the signum of x minus 5 over 2 minus 1. Right? So when you put that in there like that, it's just saying you're basically applying the signum function to that. We're not just squaring it or anything else like that. That's why we get to use the little abbreviations. So I know then that it's a signum function because that kind of gives it away. G of x would be equal to the absolute value of x over x. I'm not even going to ask you to use your arms on this one because I'm not sure how we could actually do this one. But yeah, because it's like 3 little sections here. You got an open circle in this way, open circle. That one would be like a super tricky, but. Do what? Oh, yeah, you can make the circles with your mouth. That's right. Y'all can be creative. What was I thinking? We could have figured this out. All right. So honestly, the fact that we've got the signum there, it really doesn't even matter. Like because we're not graphing it right now anyway, we are just talking about the transformations, and those work the same no matter what. However, you do have to make sure that in all of the stuff that you're doing with your x's here, that you always have this factored all the way out. Like if this wasn't factored out, it's got to be factored out completely. You should have a 1 in front of that x. If you don't, then that changes this number and whatever's going out here differently. So this is kind of factored out, but what's inside these little parentheses here, that x minus 5 over 2, I don't want you doing weird things with what's going on. Isn't this the same thing as 1/2 times x minus 5? Yes? And so I'm going to write it that way so we don't get confused with what's going on. So basically I factored out the 1/2. It didn't affect my numbers and stuff in there, but I'm not trying to use 5/2 in anything right now. All right, so then here's what I know. Let's see. There's not any negative signs, so we don't have any reflections. The only multiplication I have going on is right here. So does that affect me horizontally or vertically? Horizontally. And this would be a horizontal what? Stretch. Good. A horizontal stretch. And the factor is what? 2. And the factor is 2. It's the reciprocal. Then I have subtractions. So this is, then I'm going to translate. The 5 tells me what? Right 5. And then 1 is down 1. Everybody okay with all that? Okay. So this is what kind of function? Absolute value. And that means g of x equals the absolute value of x. And we've already done that one, so we know it looks something like that. So this negative, yes. This negative means that I'm going to reflect, and I would reflect in what? The y-axis. This is happening inside the absolute value. Let's reflect in the y-axis. Then that 1/3, does that 1/3 affect me horizontally or vertically? Horizontally. So this is a horizontal what? Stretch. And then the factor is 3. And then I'm going to translate. Good, right? 4 up 7. We all good? Yes? Okay. So then this is what kind? Cubic. So f of, or g of x, dang it, g of x is equal to x cubed. And we've already done this one too, so we know it should look like this. All right, so that negative means I have a reflection. What am I going to reflect in? Okay, I'm going to reflect in the x-axis because it's outside of my cube there. Then this 3/2 affect me vertically or horizontally? Vertically, and it's a vertical what? Stretch. And the factor is what? 3/2. And then I'm going to translate left 3 down 8. Okay? Everybody good? Any questions at all? Awesome. All right. On the back here, it says using the graph of each function, identify the parent function, then write an equation for the function under each transformation. So this is kind of a little bit of the opposite of what we just did. We have this picture. What is this thing? Absolute value. So we write the name, absolute value, and we're going to say f of x equals the absolute value of x. So it says translate 2 units right. So if I'm going to translate it 2 units right, does it happen inside or outside my absolute value? Inside. So this is going to give me g of x is equal to the absolute value of x, then what? Minus 2. And that's it. So now we're going to take the parent function, we're going to reflect it in the x-axis and translate it 5 units up. So g of x equals. If I reflect in the x-axis, does that negative go inside or outside? Outside. Outside, the absolute value of x. And then, so the only other thing I'm doing is translating 5 units up. Does that happen inside or outside? Outside. So I close that off, plus 5. Okay. Everybody good with that? Yes. All righty. So I'm going to give you a minute or two, and I want you to work on number 12. All righty. Ivania, can you tell me what this is called? Reciprocal. And that means that f of x would equal what, Ivania? 1 over x. All right, awesome. Thank you. All right. So then I'm supposed to translate 7 units down and 3 units up. So David, that would give me g of x equals, so David, what goes with the x? Okay, so 1 over x plus 3 and minus 7. Okay, y'all agree with that? Yes? Okay, good deal. All right. So C, thank you. Ricky, on C, how many terms do you have in the end? Like how many terms would this side of the equation be on on C? Just 2 terms? What would they be? 1 over 3x minus 2. So g of x equals 1 over 3x, and then minus 2 goes out here. Okay, y'all agree with that? No. No, why not? 2 units right, it's going to have to be down here. We agree with that? Okay, very good. So let's back up just a little bit. Let me write this as, so g of x is equal to, all right, so I'm going to horizontally stretch by a factor of 3 and translate 2 units right. So if this is going to be 1 over, now this is 2 units right is going to be my x minus 2. You agree with that, Ricky? Right, okay. So then my horizontal stretch is multiplied by x, right? And then if I do that, that's a 1/3 right here, but would we leave a fraction in the denominator like that? No, we would not. So we multiply by the reciprocal, and you actually get that g of x is equal to 3 over x minus 2. So check this out. This is a horizontal stretch by a factor of 3, right? I can rewrite this 3 over x minus 2. Doesn't that equal 3 times 1 over x minus 2? So not only is it a horizontal stretch by a factor of 3, but could be a vertical stretch by a factor of 3, because for your reciprocal functions, they're the same. Okay, we good? Any questions about that? All right, so we're eliminating this one. The other one that was a step function, we changed it to a signum. I'm not going to do that on this one, but this is the greatest integer, or the step function. It doesn't really have any applications for anything anybody cares about, so we just took it out. All right, so 14. What's our parent function here? Cube root. So this is a cube root. Okay, and so f of x is equal to the cube root of x. So I'm going to reflect in the y-axis and translate 4 units right. If I reflect in the y-axis, does that negative go inside or outside? Inside, because it's going to affect the x. So this is going to give me g of x. It's going to go on the inside. So cube root of negative. And then I'm going to translate 4 units right. So I go inside or outside? Inside. And this would be x, what? Minus 4. Are those parentheses there important? Yes, they absolutely are. Okay. Then I'm going to horizontally compress by a factor of 1/2 and translate 5 units down. So g of x would equal, so that horizontal compression, inside or outside? Inside. So cube root of, what do I multiply by x? 2. 2x, and then does that 5 go inside or outside? outside, minus 5. When you do something like this, be very careful that you're not sloppy with your root sign and make it difficult to tell if you meant for the 5 to be inside or outside. Does that make sense? Make sure it's real obvious in what you're doing. We good? All right. 15. If the function f of x equals 2 times x minus 5 squared plus 3 is reflected across the y-axis, then translated right 6 units and down 2 units, write the equation of the new function. Basically, we're doing the same thing. We're just not starting with the parent function. Okay, we're starting with what they gave us. We're going to reflect it across the y-axis. So does that affect the sign inside or outside? Inside, right? And then I translate right 6 units. That also affects the inside, right? And then down 2 units, that affects this. So does anything I'm doing affect that too? No. So I can go ahead and write g of x is equal to 2. Then, since it's reflected, I need a negative inside of here, parentheses, and then I'm already at x minus 5. If I'm going to go right 6 units, this will become x what? Minus 11, good, squared. And then I'm at plus 3. I'm going to go down 2 units. That makes this plus 1. Everybody okay on that? All right, now 16 says the function was vertically stretched by a factor of 2, then translated 2 units left and 5 units up. The resulting function is represented by this. Write the equation of the original function. So it's like 15, but we're going the opposite direction. You're not going all the way back to the parent function, just to whatever it looked like before this. So think yourself through that while I pass out your assignments. Okay, so if it was vertically stretched by a factor of 2, that affects this 6, right? So if it was stretched by a factor of 2, and now it's a 6, what was it before? 3. Okay. And then translated 2 units left, so that's going to affect that right there. So x, and then if I'm at x plus 4, if I had to go 2 units left to get there, where was I before? X plus 2. And then 5 units up, minus 6. Okay. Everybody okay with that? Any questions? Okay. Make sure you're paying attention to which direction you're going on these, because I think you can handle it either way, but I think it just depends on what, you know. All right, so now if you look at your homework on number 5, change number 5, because that's that greatest integer that we skipped, and change it to the signum. So f of x equals signum of 1/2 x plus 5.